Hello, class, and good day. Welcome back to your ESI 124 and your engineering mechanics 2 or your dynamics of rigid bodies. And for today's video, we are going to talk about the planar kinetics of a rigid body, force, and acceleration. Now, in this lesson, we will just introduce the methods used to determine the mass moment of inertia of a body, develop the planar kinetic equations of motion for a symmetric rigid body, and discuss applications of these equations to bodies undergoing translation, rotation about the fixed axis, and general plane motion. But before we go to our main topic for today, let's just have a quick recap of what we have discussed last lesson or your lesson 5, your kinetics of particle, force, and acceleration. On lesson 5, we did explain the Newton's second law of motion. We did discuss also the equation of motion is all forces um, acting on a body is equals to mass times acceleration. And we also derived that equation of motion for a system of particles. And we also derived and explained the equations of motion when using rectangular coordinates. We also derived and explained the equations of motion using the normal and tangential coordinates. And we also solve problems related to Newton's second law of motion and equation of motion, rectangular, normal, and tangential coordinates. So much for the recap. So let's proceed to our main lesson for today. And for our lesson contents for today's video, we are going to talk about the mass moment of inertia, planar kinetic equations of motion, and lastly, your equations of motion in translation. Okay, so our learning outcomes. At the end of the lesson, the student must be able to explain the principle of planar kinetics of a rigid body, review the principle of moment of inertia, and derive and discuss planar kinetic equations of motion, and lastly, solve problems as usual and moment of inertia and equations of motion and when your body is in translation. So, so planar kinetics of a rigid body. This is the episode one or the part one of the lesson. Since this specific lesson, the lesson six is um, should be tackle 2 weeks. No, 2 weeks siya. So I decided to divide it into two para hindi siya masyado madami for just one episode or for a one isang bagsakang video lang. So hinati ko sa dalawa. So this is your episode 1 or your part 1 of your lesson 6. Okay, so part 1, we are going to talk about the mass moment of inertia. So mass moment of inertia, no? Also called as the moment of inertia, angular mass or rotational inertia, is the measure of the resistance of a body to angular acceleration. So kumbaga, itong mass moment of inertia is just the resistance of our rigid body to resist the angular acceleration of the caused by a force or a moment, no? Okay, so it can be computed using the formula of this one. Moment is equals to the moment of inertia times the angular acceleration. So where m is your moment, I is the mass moment of inertia in kilograms meter squared or slug feet squared, no? And your alpha will be your angular acceleration in rad per second squared. Now, when we say planar kinetics, now we're involving here the angular motions. No, if we talk about the planar kinetics, or just like the previous lesson natin sa midterm, yung planar kinematics, no, we did, yeah, when we say planar kinetics, it involves angular motions. So, yeah, mostly babalik tayo sa dating gawin, yung angular acceleration, angular velocity, and we uh, also expect na babalik yung no, no, the normal and tangential coordinates or components of the acceleration kasi nga it involves angular motion or angular parameters. No? Okay? So, ayun, to compute the moment, no, the mass moment of inertia is, oh no, to compute the formula for the moment using the mass moment of inertia is m is equals to moment of inertia, mass moment of inertia, which is your I, times the angular acceleration of your body. Okay, so by comparison, no, medyo, yeah, it's kind of identical, no? It's or familiar sa equations of motion. So when we say for the second law of motion of Newton's law, second law, no? By comparison, the moment of inertia has the concept or same way with F is equals to mass times acceleration. This is your equations of motion, kumbaga, or the Newton's second law. So where the mass is a measure of a body's resistance to acceleration. Now, in inertia or mass moment of inertia, ang nakaka-identical lang nila is that if sa F is equals to ma, yung mass mo yung nagre-resist sa acceleration. In inertia naman is your mass moment of inertia, which is your I. No? Magre-resist siya sa angular acceleration of the motion. So, kumbaga, ito lang kumbaga yung um, same way or same sense ng F is equals to ma, which is m is equals to ia. So, I alpha, rather. So, your F is the moment for the moment of inertia. Your m is your mass moment of inertia, and your acceleration is same sense pa rin sa angular acceleration when we are talking about mass moment of inertia. So, ano lang siya. So one of the practical applications considering mass moment of inertia is the connection, no, of flywheel to an engine. Kumbaga, every engine has a flywheel. Kumbaga, sa tractor, let's say, for example, meron tayong tractor and it has flywheel na naka-attach sa engine so that our tractor will um, able to operate, no? So, for instance, as shown in the figure, the flywheel on the engine of the tractor has a large moment of inertia about its axis of rotation. Kumbaga, ito yung axis of rotation niya pa. Kung lalaki talaga yung moment of inertia when we say uh, malaki yung flywheel. We say um, the greater the radius of the flywheel, the greater large moment of inertia. So, kumbaga, no, so in other words, no, of to make it an example sa mass moment of inertia for is on the real um, sense, no, say your flywheel to an engine is um, it has a large moment of inertia about its axis of rotation. Why? Bakit kailangan ng ganyan? So, when set to motion, the flywheel has a several purposes, and one of which is to provide mass for the rotational inertia to keep the engine in motion. Kumbaga, although maraming pang silbi yung flywheel, no, to for the engine. So one of its functions or purposes is to provide the mass for the rotational inertia so that it keeps on moving, no, after it applied a starting movement, no, yung flywheel mag papatuloy na mag-rotate until it will come to a point na bibilis at bibilis siya so that it will keep a rotational motion to provide power to the tractor. Okay? So this will prevent the engine from stalling or idle time or idling, and instead will allow it to maintain a constant power. So, kumbaga, ito lang yung baga application or an application for a mass moment of inertia in flywheel to an engine sa tractor. So, the moment of inertia is defined as the integral of the second moment about an axis of all the elements of mass dm which compose the body. Okay? So, the moment of inertia is, let's say, the moment, di ba, yung formula to solve for our moment is the moment of inertia times angular acceleration. Now, we already know how to compute for the angular acceleration. Now, let's focus muna for the mass moment of inertia. So, paano ba to kino-compute, no? Hindi siya actually given na as a problem na ito for this problem, ito yung mass moment of inertia niya. So, mostly for or all of mostly of the problem na ibibigay dito sa planar kinetics is hindi siya kumbaga given na agad yung mass moment of inertia. We should compute for the moment of inertia with the given parameters of the problem. So let's explore I'm sure nadaanan nyo na to sa mga previous uh, say courses nyo, no? But let's have a quick review for that. Kung ano ba tong mass moment of inertia, how to compute for this mass moment of inertia. Now, moment of inertia is defined down as the integral, okay, integral of the second moment about an axis. So when we say second moment is it involves moment arm, ganon. So it's when we say second moment, it will be squared, no? Okay, so about an axis of all the elements of mass dm which compose the body. So for example, as shown in the figure, the body's moment of inertia about the z-axis, yan. Okay, kumbaga let's say ito yung element na kinuha natin sa whole body na compose sa body natin. So let's say this one is our dm, this small element or the dm, no? To compute for the moment of inertia of this body, by definition, I is equals to the integral of the second moment, which is r squared, times dm from m to its upper limit, no? So for the moment of inertia or mass moment of inertia, no? It is equals the integral of r squared. This is the radius or the radial distance of the particle to the axis, no? Or the center or the axis, whatever nilagay yung axis nyo, basta yung r squared is the distance between the particle to the axis. Okay? So that's how you compute your mass moment of inertia. Now, what is I? This is the mass moment of inertia, and R is the moment arm. Oh, yeah, basically the moment arm. When you say moment of inertia, meron talaga yung moment arm. So it is the perpendicular distance from z-axis to the arbitrary element Tm. Okay, that's what I said kanina. And M is simply the mass of the arbitrary element Tm. Okay? Okay. So, since the formula involves the moment r, the value of I is different for each axis about which it is computed. Kasi nga, hindi siya, constant. Yung, ano nyo, moment arm from, let's say, for this, at this point, iba yung R nyo. At this point, iba naman yung R nyo. Sa ibaba, iba naman yung R nyo. So, it will be different. So, it is really safe to use integration when it comes to this. Kasi nga, variable yung, R or the moment R. Okay, so, kumbaga, ninote lang dito na hindi palaging same yung moment, no, no, the value of our moment of inertia because our moment arm changes along its axis. Okay? Now, in the study of planar kinetics, the axis chosen for analysis generally passes through the body's mass center G. And us, remember, it is always perpendicular to the plane of motion. Again, in the study of planar kinetics, the axis chosen must pass through the body's mass center G. No, we denote that as G as the mass center of the body, and is always perpendicular to the plane of motion. Okay, so that's it's a given na talaga or a rule when we study planar kinetics. Okay, dapat yung axis mo mapapass through the center of mass and it's always perpendicular to the plane of motion. Okay, so its moment of inertia will be denoted as I sub G. Now, G is just a patandaan na itong mass moment of inertia ito is yung axis natin is nag-pass through the body's mass center or G. Okay? So, since R is squared in equation 6.1.1, yung I is equal to integral of R squared dm, the mass moment of inertia is always a positive quantity. Kasi nga, square ng negative value is positive or lalo na pag positive yung ni-square mo, lalong magpa-positive. Okay? So that's, inote lang dito na always positive quantity yung mass moment of inertia natin. Okay? So common units used for I sub g or the moment of inertia are kilograms, meter squared, or slug feet squared. Okay? Na common units lang siya. Okay, so if the body consists of material having a variable or different density, say rho is equals to rho of xyz, the elemental mass dm of the body can be expressed in terms of its density and in volume using the formula of density. Ano bang ibig sabihin nun? So, if yung body daw consists of material na hindi the same yung density, and the elemental mass of can be expressed in terms of its density and the volume using the formula of the density. Since we already know that the compute for the density is mass over volume, therefore mass is equals to rho v, or the density times the volume, and your dm is equals to rho dv. Okay, so therefore then sa yung value na to substitute natin sa original na formula. Ayan, then substituting equation 6.1.2 to equation 6.1.1, we have our 6.1.1 na form na equation. I-substitute down natin yung value ng dm in terms of dv. Okay? So that would be equal to I is equals to integral of r squared rho dv. This is your mass or differential mass na kinumute natin in terms na sa volume ng body natin or differential body natin. Okay, so the body's moment of inertia can be computed using the volume elements VdV by integration. Okay, so we can actually compute pala the mass moment of inertia in terms of volume, given that the density of the body is given. So if the density is constant, then we can go factor rho out of the integral, and the integration is then purely a function of geometry. Kasi nga, um, by length to eh. Length ang R, length din yung volume or area or volume talaga mismo. Okay, so yeah, we're involving geometry like this. Kanina, mass, involving with mass. Now, we're going to functions of a geometry. Kasi nga, we say that the density of if the body of the whole system is constant, then I is equals to rho integral of r squared dv from v to the upper limit. Okay? That's how you compute for the mass moment of inertia in terms of volume, of its volume. No? Now, there are two ways to solve for mass moment of inertia. First is your shell element. So in this lesson, we will consider only symmetric bodies. Symmetric. Take note, symmetric bodies lang. Having a volumes which are generated by revolving a curve about an axis. Let's say, a curve natin dito is semi-parabolic. And then if you rotate that one, it will create something look like this. No? So if you rotate that about an axis, let's say our axis here is the z, and if we rotate this curve, this one, this one, this one, if we rotate that about the z axis, no, it will create a somehow, a shell. Kumbaga. So let's call a shell. So yeah, when we rotate this elemental or elemental dm, we rotate that one or the whole curve of um, the body. If we rotate that one about an x-axis, it will create this one. And then how to compute this moment of inertia of this kind of body. So an example of such body is shown in a figure. And specifically, we will consider two types of differential elements that are generated by revolving a curve about an axis, which are the shell element and the disk element. So there are two types now of differential elements that are generated by revolving a curve about an axis. So if we are going to rotate a differential element about an axis, there are two ways to solve it: the shell and the disk element. So what and how to solve the moment of inertia when we are going to use the shell element. So as shown in the figure, say first muna tayo sa shell element. Let's talk about shell element. Okay, so if a shell element having a height z, having a radius r is equals to y, let's say this is your r, which is equals to y, and the thickness is dy, the thickness of our differential element. Kumbaga, let's have a bigger picture. If this is the our differential element and it has a thickness of dy, kasi nga dito yung axis niya or thickness niya nasa axis ng y. Okay, so that's uh, we state that the thickness is dy kasi nga along it's along y axis siya. So ayan, so given natin is height is z, radius is r is equal to y, and thickness is dy. So the volume now will be equal to the circumference times the thickness, times the height times the thickness. And that's how you compute for the volume of the shell element. Okay, again, circumference, which is 2 pi y, since the radius is y, and I took it for the circumference is 2 pi r, and then the height is z, and then if we find the product of the three values, we'll get the volume, okay, the differential volume of our element. So in equation 6.1.5, or this one, can be used for determining the mass or the moment of inertia, I sub z, or the moment of inertia in z-axis of the body about the z-axis by substituting it either equation 6.1.3 or 6.1.4. Kanina ang mga equations. No? So, how it would look like. So, the reason is that the entire element, due to its thinness, so, baka nipis niya, lies at the same perpendicular distance r is equals to y from the z-axis as shown in the figure. Neto. So, and so the substituting equation 6.1.5 to either sa equation 3 and equation 4 of this lesson, now we get I sub z is equals to rho integral of r squared dv. Now, since we already have the differential volume of our shell element, then we can substitute that one. So it will be now I sub z is equals to rho integral of y squared. Since the radius for our our body or the shell element is y, that will be square 2 pi y z times dy. Okay, so that will be equal to y squared times y, that will be y cubed, and then multiply mo lang lahat, so that will be 2 pi z y cubed dy. Para naman ma-easy natin itong dy, the purpose of the dy is to we don't have any issue when we are going to integrate na these values. Okay, now as shown in the figure, so that's how we solve for um, the moment of inertia using shell element. So this is your formula na. So if you're given with the density of the body, the height of the body, you have, since those are constant values, then after you this 2 pi z, labas mo lang, and then matitira dito is y cubed dy, and then if we integrate that one, that will be equal to rho 2 pi z y to the fourth over 4 plus c. So that will be equal to your mass moment of inertia about the z axis. So how about the disk element? Paano ba to? So as shown in the figure, if the disk element having a radius y, ayan, radius natin is y, and the thickness is dz, since it's in the z-axis, no, is chosen for integration, then the volume is equal to the volume of a cylinder is pi r squared times height. So therefore, to find for the volume of the disk, since it's kind of look like the cylinder, okay, solid man siya, or it's solid. So we can say that cylinder lang to pero medyo short. Okay? So, that will be equal to pi y squared dc. So, ito yung differential volume niya for the whole body, no? So, this element is finite, and the radial direction and the consequent its parts do not all lie at the same radial r from z axis. So, what does it mean? So, sabi dito, hindi constant yung just the radial distance. The radial distance is from the center, no? From the center of to our element, no, that will be your r. Now it says that hindi daw siya same all along the z-axis kasi nga mas malapad dito, so mas malaki yung radius niya dito in this part, this part is medyo maliit na hanggang maging zero hanggang dito sa top, no? So, sinasabi lang dito, to solve for that kind of um, body, then we can use integration. Now, what kind of, how to solve for using the integration? Then you can use the disk element. So, same pa rin yung process since we already have the volume or the differential volume for our disk element. Then we can solve for the moment of inertia about the z-axis. So, as a result, equation 6.1.6 or the pi y pi z squared pi y squared times dz, substitute natin sa I is equals to integral of r squared dm, no, dv, no? So, cannot be used to determine I sub z directly, no? Why? So, instead to perform the integration, it is necessary to determine the moment of inertia of the element about the z-axis and then integrate the result. So, kailangan po natin yung i-determine lang muna natin at that point or at that element yung moment of inertia niya. Then we just have to integrate from 0 to its our upper limit to solve for the whole moment of inertia of the whole body. Okay? So, pero form lang dito na hindi pala siya direkta na masosolve. Hindi hindi kagaya ng shell element is the whole na talaga, whole element na ng, a whole body na talaga makakompute mo doon. Okay? So this element naman is you have to find for the moment of inertia of that element. And then after you find that one, i-integrate mo siya from its upper limit, from its lower limit to the upper limit. So have your whole moment of inertia of your whole body. Okay? So, for example, let's have an example using the shell element. So, determine the mass or determine the moment of inertia of the cylinder shown in the figure about the z-axis. The density of the material is constant. Okay? So, this is your cylinder. It has a radius of r. The center of mass or the mass center of the body is at O, point O. And then the height of this is h over 2 plus h over 2 is this one, h. So, klaro pa dito, yung thickness niya using a shell element, no? Ito kung pag mag-use natin ng shell element. Then, how to solve this one? How to find the moment of inertia of the whole cylinder? So, we are going to use shell element, okay? For the given, this one, the required is the moment of inertia of the cylinder about the z-axis, okay? So, shell element can be used to solve this problem. So, first, find the differential volume of the cylinder, dV, then solve differential mass, dm, using the density formula. Okay, so, paano ba yan? So, dV is equals to circumference times thickness times the height. And then, for our circumference is 2 pi r. The thickness is dr, since you already have this one. The thickness for our shell element is dr. And then for height. Okay? Or dv is equals to 2 pi rh dr. Okay? So then, it is equal now to rho is equals to dm over dv, and then your dm is equals to rho dv. So this is how you solve for your dm para ma-substitute natin sa formula ng moment of inertia. Okay, so that will be dm is equals to rho times 2 pi rh times dr. So that's your equation 1. Okay, so with that, since the entire element lies at the same distance, r, di ba? Kasi nga, cylinder siya. So, same lang yung r, or the distance from the z-axis of the moment of inertia from of the element. So, since constant lang yung r niya, hindi nag-change. So, therefore, d I sub z is equals to r squared dm. So, di sub z is equals to r squared. Substitute natin yung volume ng dm in terms of volume, no? So that will be rho times 2 pi rh. This is your volume of the cylinder, rh dr. So that will be d I sub z is equals to rho times 2 pi r cube h dr. That's your equation 2. Okay, so integrating equation 2 with limits of integration from 0 to r for dr for the whole body na talaga from 0 to r. Okay? So di sub z is equals to rho 2 pi r h 2 pi r cube h times dr. Then we have to integrate both sides. So that will be integral of di sub z from 0 to I sub z is equals to integral of rho times 2 pi r cube h times dr from 0 to r. Okay. So we're rho and h are constant. So your density and your height is constant. So you can make it labas from our integral. Okay? Para maging simple siya tignan. Okay. So I sub z now is equals to, since I sub z, integral of I sub z from 0 to I sub z is I sub z minus 0. So that will be I sub z equals to the rho times 2 pi rh. Nilabas yung mga constants. And then integral of r cubed dr from 0 to r. So that will be equal to rho times 2 pi, r, 2 pi h times r to the fourth over 4 from 0 to r. Then, substitute mo lang yung mga values sa mga limits mo. Then, I sub z is equals to pi. No, rho pi h over 2. Since 2 over 4 is 1 half, so that will be over 2. Times, substitute mo yung value ng r to be r, your radius. So that will be r to the 4. No? So that will be equal now to I sub z is equals to rho pi r to the 4 times h over 2. Solve the mass m by integrating the equation. Equation 1. Then integrate natin yung equation 1 natin kanina. So for the mass, okay, so integrate lang natin both sides. So that will be integral of dm from 0 to m is equals to the integral of rho 2 pi rh times dr from 0 to r. Okay, so mass is equals to rho times 2 pi h, the constants, nilabas na yung constants. So integral of r dr from 0 to r. Then m now is equals to rho times 2 pi h, r squared over 2, since the integral of r dr is r squared over 2. So that will be equal to, cancel out mo yung 2. So matitira na lang is rho times pi of pi h, r squared minus 0 squared. So that will be equal to yan. So m now is equals to rho times pi h r squared. So that's how you solve for your mass. Then substitute equation 4 to equation 3 to solve I sub z. So I sub z is equals to rho times pi r 4 h over 2. So yung density mo is equals to mass over pi h r squared times pi r to the 4 h over 2. So that will be equal to pi sub z is equals to 1 half times mass times r squared. So ito pala yung formula mo when you are given with a cylinder. So when the problem is cylinder, ito yung formula na gagamitin mo. The mass of the cylinder, the radius of the cylinder squared mo yun, then half of it will be your moment of inertia about the z axis. So that's how you solve for the moment of inertia what z axis using shell element. So that's how you solve for it. Okay? So another theorem na nag-involve sa pag-solve ng moment of inertia of a body. Let's say, if the moment of inertia of the body about an axis is passing through the body's center is known. Yan, known daw yung moment of inertia. No? Then the moment of inertia about any parallel axis can be determined by using the parallel axis theorem. So, ano daw? So, if yung moment of inertia na nag-pass through sa bodies of center is known, then you can solve for the moment of inertia parallel to the axis na nag-pass through. Let's say yung z prime, since it is, let's say it's known, kasi nga yun yung given sa statement. So, yung z prime, you already know what's the moment of inertia of the z prime. Then you can solve for the z. Kumbaga, yun lang yung thought dito. Kasi, okay? So, if you can solve for the moment of inertia of the z by using the z prime's moment of inertia. That's how you call the parallel axis theorem. So that's how the theorem does. So consider the body shown in the figure and use it to derive the theorem. Okay, use this one. Let's use this figure to solve for that or to derive the theorem kung tama ba talaga to. So the z prime axis passes through the body's mass center G, whereas the corresponding parallel z-axis lies at a constant distance d away from G. Okay, you can see here the figure. Yung distance daw ng z na axis has a distance of d from the center, no? From the center of G. Okay? So selecting a differential element within the body of mass dm, and as shown, it is located at point x prime and y prime. You can see for the differential mass of the body has a distance of y prime and x prime away from G. Okay? So that's how your differential mass looks like. So by using the Pythagorean theorem, we can solve the distance of the differential mass up to the point A, and you can see here, and express the moment of inertia of the body about the AZ axis. So for the ano ba yung mass moment of inertia of the z axis to our body? So that for that we can use the Pythagorean theorem so that we can solve for the radial distance or the radial distance away from the point A to our differential mass. Okay, so to use for using the Pythagorean theorem, that will be r squared is equals to the distance of the x, no? So that will be d plus x prime. Tama? So d plus x prime, that's your whole base ng triangle natin. Okay, so that will be d plus x prime squared plus the height or the height of the differential mass from our x prime axis. So that will be y prime squared. So then using this equation 6.1.1, we have I is equals to integral of r squared dm from m to the upper limit. So substitute lang natin yung value ng r squared natin. That will be d plus x prime squared plus y prime squared dm. Okay, expand mo lang. After expand, d squared plus 2dx prime plus x prime squared. Okay? Plus y prime squared. So, magiging dito na siya. Distribute each terms yung integral natin. So, that will be integral of x prime squared plus y prime squared dm plus integral of 2. Ito na term. Second term natin. 2 dx prime dm. Third term natin will be no. Yeah. Kumbaga, ginloop yung x prime squared plus y prime squared kasi meron siyang value later. Okay? So that will be the first integral, that will be x prime squared plus y prime squared dm plus the second integral is 2d prime dm plus no plus pa siya dito d squared dm. Okay? Meron pa siyang plus dito. Okay, may plus pa dito siya plus. Okay? So that will be, ayan, medyo na may plus na siya dito. So that will be integral of x prime squared plus y prime squared dm plus 2d, since constant yung 2 and d. So labas mo yan. So integral of x prime dm plus d squared integral of dm. Ano man, as you can see, marami siyang terms. So actually, it has something, meron siyang value in each terms. So let's derive that one. So ano ba itong first integral? So note that the distance d is constant and shown. Ayan. So distance of differential element dm from mass center of G. So r prime squared, don't be confused ha. Yung r prime squared is the distance from the body's center to the differential element. So that's what you call r prime squared. Okay? So, implication of equation 6.1.7, yung maraming terms, yung tatlong terms natin. So, we are going to um, see what are the implication of that equation is, or are, okay? Okay. So, ano ba yung first equation? Diba? As you can remember, yung first equation natin is the integral of x prime squared plus y prime squared dm. And it has value. So that will be equal to I sub g. Since r prime squared is equals to y, x prime squared plus y prime squared, di ba? as we already know sa pag-solve natin sa mga mass moment of inertia, which is integral of r squared dm. Okay? Since makikita natin dito na yung mass, the moment of inertia of our differential element is equals to ito lang, kumbaga. 'Di ba? Kasi nga, yung distance ng, yung distance ng r prime natin using the Pythagorean theorem is x prime squared plus y prime squared. And that will be um, shown on our first integral, which is x prime squared plus y prime squared. So this is actually equal to r prime squared. Thus, yung first integral natin pala is equals to I sub g, which is I sub g is equals integral of I prime squared dm. So we can just say na yung first term pala is the moment of inertia of the center of our body. Diba? So I sub g. So that will be equal to r prime squared dm. Okay, for the implications, again, for this equation, for the second integral, since that was the first integral, so what is happening sa second integral natin? Again, so sabi dito, integral of x prime squared plus y prime squared times dm is equals to 0. Bakit? Now, since the z prime axis passes through the body's mass center, so anong ibig sabihin na bakit 0? Kasi nga, wala siyang radial distance from the center of mass kasi mismo axis niya nag-pass through sa body's center. Therefore, wala siyang moment of inertia. Kasi nga, you can actually um, picture it out. Kasi nga, when we say moment, no, meron talaga siyang moment arm. Kung wala siyang moment arm, wala din kayong moment. Kasi hindi siya mag-moment at that point, di ba? Let's say, yung z prime axis, as you can see, wala siyang r. Di ba? So you can easily say na, zero pala yung uh, value dun sa z prime. Kasi nga, z prime lang to di ba? X, r squared dm. Di ba? So this is actually not the, no, this is wrong. Actually, this is not the second integral. The second integral is x prime dm. Diba? Second integral is 2d x prime dm. Not this one. Kasi nga, I sub g2 eh. So this is your second integral. So what happened here is that the integral of x prime dm 2d. So ito pala yung um, integral na nag-pass through sa center natin sa z. So we can say na ang second integral is 0. So how about sa third integral? So ang third integral is d squared integral of dm. No? From m to the upper limit. So represents the total mass of the body. As you can see, para siyang kinocompute mo lang dito yung whole mass ng body using integration, which is you get the differential element of the whole body, and then you integrate that from 0 to m, then you can have your total mass of the body. Okay, so that's your total mass of the body pala. It's how the third integral works. So kinocompute lang niya yung whole mass ng body mo. Okay, so that will be d squared times the integral of dm from 0 to m. That will be equal to d squared m, or md squared. So that's your third integral. Therefore, the moment of inertia about the z-axis now is, from this one, na-simplify natin by evaluating each terms sa mga integral natin. We did simplify it down to I sub g plus md squared. Ayan. So, if you already have the mass moment of inertia from g, the body subcenter of the mass moment of inertia of the body to the center, plus the whole mass of the body times the d squared. Now, don't forget that the d is the distance of the axis from the body center's axis. So this is how to solve for the moment of inertia about the z-axis. So that this is how your parallel axis theorem was derived, no? And that will be I is equal to I sub g plus md squared. Always remember this one kasi nga, it is very useful when we are going to solve for the moment of inertia of a body away from its center's mass. Okay? So where I sub g is the moment of inertia about the z-axis passing the mass center g. Now the m is equals to mass of the body. D is equals to perpendicular distance between the parallel z and the z prime axis. Okay? So that's how your parallel axiom theorem does. Okay? So next is the radius of gyration. So sometimes, not always, no, the moment of inertia can be solved about a specified axis. No? The moment of inertia of a body about the specified axis can be determined using the radius of gyration. So another way of solving for your moment of inertia is your radius of gyration. So ano ba to? So it is a geometrical property which has the units of length. So when k and the body's mass m are known, the body's moment of inertia is determined using the equation of this one. So kung given na yung k nyo and the body's mass, then you can solve tayon, or you can solve directly your I to be equal to just find the product of the mass of the body and the k squared. Or you can solve for your k as equals to square root of I over m. Okay? So another is the composite bodies. So composite body refers to any body consisting a number of simple shapes such as discs, spheres, and rods. Kumbaga hindi siya uniform all of the body. Okay? So the moment of inertia of a composite body about any axis can be determined by adding algebraically the moments of inertia of all the composite shapes computed about the axis. Thus, the formula is I is equals to the summation of I sub g plus md squared. Kasi nga, susolve mo yung, kumbaga, let's say, meron naman na example later. So, let's say, for example, meron kang disk or meron kang washer. So paano ba yung i-complete mo yon? Kasi nga meron siyang uh, inner radius and outside the radius. Then that's kind of complicated when kasi nga if you're going to use the outer radius, it will implicates that the kinocompute mo na mass moment of inertia is the whole disk na ng radius is uh, the outer radius. Yun lang. Pero ang kailangan ng problem is the washer only. What is the moment of inertia of that washer? Say, look like a washer. Then, if you're going to use the outer radius lang, no, you are computing actually of the whole disk. No, hindi siya washer, kundi solid disk talaga siya. So, ang gagawin mo doon is you're going to find the outer radius moment of inertia and the inner radius subtract mo yung outer minus inner, then you can have your moment of inertia of the washer. Okay? For example, let's have an example for an uh, easy understanding, no? Two problems na nag-involve ng opposite bodies. So, I sub g is the moment of inertia passing through the mass center g for each the composite parts, and is determined by integration. Okay? Meron siyang yung kinabit natin kanina. Okay, so algebraic addition is necessary since a composite part must be considered as a negative quantity if it has already been counted as a piece of another part. For instance, a whole. So subtracted from a solid thing. For example lang ha, kumbaga, yun nga, for, let's say for a washer, meron siyang hole sa gitna. Then, yung hole na yun, you will compute that hole where you assume na solid siya. Then, if you compute that hole, ilan ba yung moment of inertia of that hole, then subtract mo yun sa solid plate na kinumpute mo rin. Then, you can have your whole body na meron siyang hole na gitna. Okay? Sa gitna. Okay? So, Just for simple ano dito, kumbaga thought ng composite bodies is you're just going to find the mass moment of inertia of each composite parts, then isasum mo lang lahat for those parts na uh, it's already been counted, then you're going to assume that as negative. And then after you identify each parts kung ano ba yun, negative o positive, then you can have the summation, and then you can have your whole moment of inertia of all of the whole composite body. Okay. So note that the parallel axis theorem is needed for the calculations if the center of mass of each composite part doesn't lie on the axis of our center of mass. Okay? So ito yung gagamitin natin, yung parallel axis theorem kung hindi siya nasa center of mass of each opposite parts. Doesn't lie on the axis of the center of mass. Okay, for example, ayan. So if the plate shown in the figure below has a density of 800 kilograms per cubic meter and a thickness of 10 millimeters, determine its moment of inertia about an axis directed to the perpendicular to the page and passing through the point O. Okay, or perpendicular to the slide. Let's say, just like that one. So, yung plate natin dito has a outer radius na 250 mm and an inner radius of 120 mm, and its thickness is about 10 millimeters. Okay, how to solve the moment of inertia of the plate. So, given, ito yung given, the plate, the density is 8,000 kilograms per cubic meter and the thickness is 10 mm. And the required of the problem is the moment of inertia of the plate about an axis directed perpendicular and passing through the point. Oh, ito sa point to ha. Ilan ang ilan yung moment of inertia niya sa at point ko. So that's the problem. Okay, so as shown in the figure, the plate consists of the two composite parts, the 250 mm radius disc minus 120 mm radius disc. Kumbaga ito yung analysis niya dito. So, compute mo yung moment of inertia na whole disk na 250 mm yung radius, i-subtract mo yung disk na 120 mm radius. So you can have your moment of inertia at point O. Okay? So to solve the moment of inertia about O, or I sub O, we must first compute the moment of inertia of each composite part about O and add their result algebraically. Okay? So for 250 mm disk, ilan yung niya? Uh, moment of inertia. So solve the moment of inertia of uh, the disk, no? Using equation 6.1.11. Ito, kumbaga using um, parallel axis theorem. So you have your I sub d sub O is equals to I sub g plus md squared, where I sub g is equals to 1 half mr squared. Okay, dinerive na natin to sa natin. So to solve for the um, moment of inertia at the center's mass. No? Ano siya? And I sub d o sub o is equals to 1 half mr squared plus md squared. So with that, solve the mass of the disk. Then mass of the disk is equals to rho times the v sub d is equals to rho sub d times par r squared times the thickness. That's the volume of the cylinder. Kasi nga meron siyang thickness, and then the area times the thickness. Yun yung volume of the whole disk. So solving for the mass, you have your density 8,000 kilograms per cubic meter by R. Your R is 250 mm. Convert natin sa meters by multiplying 1 over 1,000. Square that 1 times the height or the thickness, 10 mm, converted to meters by 1 over 1,000. So your mass is equals to 15.708 kilograms. So medyo mabigat-bigat konti. So then I sub D sub O is equals to 1 half the mass times the thickness squared. Oh, no, 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 not the thickness. The radius away from the center, no? Or the distance away from the center from the point O. So that will be 0.250 m squared plus 15.708 kilogram your mass times d, the distance of the point from the center of the mass. So that will be 0.250 m squared. And therefore, your moment of inertia of the disk at point O is equal to 1.473 kilograms meter squared. Okay, so we already have our moment of inertia of the disk. Next is the moment of inertia of the hole. Ayan, yung butas. So for the 125 millimeters disk, solve the moment of inertia, I sub h, denote that as the whole using equation 6.1.7.11, the moment of inertia using parallel axis theorem. So that will be I sub h sub o is equals to I sub g plus md squared is equals to 1 half mr squared plus md squared. Okay, so solving for the mass of the disk, same pa rin sa pagkuha natin kanina. So that will be mass of the whole is equals to the density of the whole times the volume of the hole is equals to the density of the hole times pi r squared times the thickness. So to solve that one, you have your density of the hole is 8 times at 8,000 kilogram cubic meter times pi times 125 millimeters times 1 over 1000 squared times the thickness. Then your mass of the hole is 3.927 kilograms. Then solving for the inertia, or the moment of inertia, is equals to 1 over 2 times 3.927 kilograms times 0.125 meters squared. I-square mo doon, tas add mo yung 3.927 kilogram times 0.25 millimeters. So, baka nagtataka kayo dito is bakit 0.25 dito tas 0.125, sir? Bakit 0.125 millimeters tas dito is 0.25 meters? So, note class na yung 0.125 is the radius of the hole. And 0.25 here is the radial distance again from the point O to the centers of mass. Although hole lang siya, pero meron din siyang contribution from the point O since it's the hole itself na baga nasali when computing, right? Hole. So, dapat yung D nyo dito, same din sa D ng whole disk nyo. Okay? Para meron din silang contribution sa each other sa whole body. Okay? Take note, class, that the D will be equal to the distance to the point O to the centers of mass. Okay? So that will be 3.927 kilograms times 0.25 squared. So therefore, the moment of inertia of the whole is equals to the 0.276 kilograms meter squared. So that is the quantity of your moment of inertia of the whole. No? This is H, not D. Okay? So D is not diameter but the distance from the mass center to the point O. Okay? Baka na ano dito kasi nga yung 0.125 is just the half of 0.25 meters. So baka man yun, ano pala yung diameter. That's not the sense, okay? Yung D again is the distance from the mass center to the point O. Okay? Take note, ha? Be careful with this one to solve for your mass moment of inertia. Okay, so since we already have the disk in the hole, therefore the moment of inertia of the plate about point O is just the difference of the disk minus the hole. Okay, so that will be equal to 1.473 kilograms meter squared minus the moment of inertia of the hole 0.276 kilogram meter squared. Therefore, your moment of inertia at point O will be equal to 1.20 kilograms meters squared. So this, this is how you solve for your composite body na problem. Okay? So you just have to subtract the whole minus the whole. and you can have your uh, total moment of inertia of the plate. Okay, I hope that clear. I hope that's clear now enough to understand how what we did here. So for the mass moment of inertia at point O. Okay, so that's how you can consist the part one of um, the lesson, which is the yun nga, sa moment of inertia. Next is the planar kinetic equations of motion. So ano ba nang nangyayari dito? Okay, so planar kinetic of motion. So this lesson mainly focused on the study of planar kinetics of rigid bodies, which along with their loadings are considered to be symmetrical with respect to the fixed reference plane. So ina-assume dito class na yung mga loadings within the body is symmetrical with respect to our reference plane. Let's say this one, this is a reference plane, your XY plane, and then you can see here the parameters, what is going on right here. So again, symmetrical siya. Consider as symmetrical, no? But yeah, basta ma-understand na natin to along the way. Why? So consider the arbitrary body shown, no? The inertial reference frame XYZ has its origin coincident with the arbitrary point P in the body, and by definition, these axes do not rotate and are either fixed or translate with a constant velocity. Again, yung inertial reference plane has its origin at point P, arbitrary point P in the body. And by definition, all of the axes from this point doesn't rotate, either fixed or it will translate with the constant velocity. Hindi pa babago-bago yung velocity within the motion or within the uh, movement of our body. Okay? So, equation of translation motion is, again, if we go back for our equations of motion, that will be the summation of all forces is equals to mass times acceleration at point G. Okay? Of the centers of mass. So where in sigma F will be the sum of all the forces or external forces acting on the body. Mass is the mass of the body, M is the mass of the body, A sub G is the acceleration of the body, center of mass G. Ayan. So, note that equation 6.2.1 is referred to as the translational equation of motion for the mass center of a rigid body. So, ang tawag dito class is translational equation of motion for the mass center of a rigid body. Okay? Next is states that the sum of all the external forces acting on the body is equal to the body's mass times the acceleration of its center G. Okay, states that the sum of all the external forces acting on the body is equal to the body's mass, itong M, times the acceleration of its mass center G. Okay, so for the motion of the body in XY plane, the translational equation of motion can be expressed in the form of two independent scalar equations, which is this one. At along the x-axis, the summation of all the forces along x-axis must be equal to mass times the acceleration uh, at the center's mass g and the x-axis, and then for the y-axis of the y component naman is the all forces or all external forces along y-axis is equals to the mass times the acceleration of the center's mass at y-axis. Okay? So using equation of rotational motion, we will be able to determine the effects caused by the moments of the external forces system computed about an axis perpendicular to the plane of motion, the z-axis, and passing through point P. Okay? So we can use pala yung equation natin kanina, yung all external forces equals to mass times the center's mass acceleration to determine the effects na ano mong yayari, yung mga effects of cause ng mga moments of the external force system computed about the axis perpendicular to the plane of motion, which is the z axis, and passing to the point P. So as shown in the figure at the top, the free body diagram of the ith particle F sub I represents the resultant external force acting on the particle. So this is one. This is your F sub I. This is your resultant external forces acting on the particle. No? So while F sub I represents the resultant of the internal, take note, internal forces caused by the interactions with the adjacent particles. Okay? So yung F nyo is external, yung small letter F here is the internal forces. So if the particle has a mass m sub I and its acceleration is a sub I, then its kinetic diagram is shown in the figure at the bottom. Okay, ayan. So this is your kinetic diagram. So that will be your m times a sub I. Now, summing all the moments about the point P, we have the moment of the external forces F. That will be, since the moment arm is R away from the point P, so that will be equal from moment about P is first your external forces is R times F sub I. Now, this is from the translational equation of motion class, ha? Your all forces, all external forces or all forces acting on the body is equals to the mass times the acceleration. Okay? Take note lang, ha? So there are two forces acting on our body, the external forces and the internal forces. Now, summing all of the moments, no? Now, the first moment is the external forces. So R times F sub I plus R times the cross product F sub I, that will be your internal forces ng act sa particle natin, which is equals to the moment of the forces, which is M sub I times A sub I. Okay? So let M sub P sub I will be equal to R. These two terms will be equal to the mass of the moment at point P sub I. So that will be equal to, from this one to this one, so that will be M sub P sub I is equals now to R times F sub I A sub I. Okay, so the moments about P, equation point 6.2.4, this one, can also be expressed in terms of the acceleration. In terms of the acceleration, your tangential and normal component. Okay, so ano na mangyayari kung in terms of um, normal and tangential? So, mangyayari dito is m sub p sub I is equals now to m sub I times r times a sub p, your acceleration at point P, yung mismong acceleration niya talaga, plus the tangential component, which is the angular acceleration times the radial distance away from the center, minus the angular velocity squared. This is your normal, di ba? Medyo familiar na siya. So this is your your normal component of the acceleration, which is the angular velocity squared times r. Ayan, so mangyari dito will be m sub p sub I is equals to m sub I times r times a sub p plus r times a times r. Ayan, minus, kumbaga dinistribute lang yung r each term sa tatlo. So, the last term are the angular velocity squared r x r or r times r from the equation above is 0 since r times r, since there are no angle, so sine of 0 is 0, so magiging 0 siya, 'di ba? 'Di ba pag compute dito sa cross product ng mga vectors is scalar quantity of the first times the scalar quantity times sine theta. And then since the angle of the two same lang naman, so there are no angles, that will be 0, so sine of 0 is 0. Then your third term ba to? Yeah, the third term of your equation here, it will be equal to 0. Okay, so therefore matitira na dito is m moment at point P sub I is equals to the mass sub I times r times a sub b plus r times a times r. Since wala na to. Since zero na siya. Therefore, magiging eto na lang na matitira. So, expressing the vectors of equation 6.2.5 with Cartesian components and as shown in the figure, r is equals to x sub x I plus yj and I sub a sub p is equals to a sub p sub x I plus a sub b sub y is j. Vector sum we have. So, kumbaga, mga components na dito in each uh, x and y, no? So, at first, and so for r, it will be x sub I plus y sub j. No, 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 not sub. xi plus yj times a sub p sub x I plus a sub p sub yj kasi meron siyang dalawang ano nito component ng x and y. Then for r naman, same din dito. That will be xi plus yj. For your a ano, angular acceleration of times r rather, that will be multiply mo lang ng ano, vector k yung angular so that you can have your scalar quantity. Also same with the moment to balance the formula or the equation, so you can have your a k, no, alpha k times your r will be xi plus yj. Okay, so then carrying out the cross product operation yields to this one. Okay, so m sub I times negative y a sub b sub x plus x a sub b sub y plus a x squared plus y a y's, I don't know, that will be alpha squared. Now alpha x squared plus alpha y squared k. Cancel out yung k, so that will be m sub I minus y times a sub b sub x plus x times a sub b sub y plus alpha r squared. Okay? So letting m sub I to be dm and integrating with respect to the entire mass m of the body, we obtain the resultant moment equation to be like this. Okay? So your m sub I will be dm na siya. So distribute mo lang each terms and then integrate each term. So this will be your final result. So that will be negative integral of y dm for the first term, a sub p sub x, plus the second term, this one, the integral of x dm times a sub p sub y, plus the third term will be integral of r squared dm alpha. Okay? Yan. So, in equation 6.2.6, the summation of the moment at point P represents only the moment of external forces acting on the body about point P. So, ito pala yung mga external forces or moment of the external forces on acting on the body at point P. No? So, these are the moments of the external forces. So, it's the tatlo. Okay? So the resultant moment of inertial forces is zero, since for the entire body, these forces occur in equal and opposite collinear pairs. And thus, the moment of each pair of forces about P cancels. Okay? So again, the resultant moment of the inertial forces is zero. Para, collinear kasi yung pairs niya. So opposite, kung i-add mo yung opposite, it will be zero. So yung point P will be cancelled out. So, magiging ano na siya. So, the integrals in the first and the second terms to the right are used to locate the body's centers of mass G with respect to P. That is, ayan. So, yung mga integral pala ng first and second terms natin dito, first and second are used to locate the body's center of mass G. So, that is your integral of y dm will be y bar times the mass, no? And then your integral of x dm is equals to x bar times m. Okay? So, y bar and x bar are shown in the figure. So, gamit pala siya para to locate yung center of mass, G. Okay? So also, the last integral represents the body's moment of inertia about the z-axis. Ayan. So, that will be I sub p is equal to r squared dm. Thus, from this one, magiging ano na siya? This one. So, that will be negative y bar m, or the mass. After we integrate each terms, ha? So, plus x bar m, a sub p sub y. Since constant lang siya, so copy mo lang yung a sub p sub y or a sub p sub x. Then, integral of this one is, yeah, the moment of inertia at the center of mass. So, I sub p, so alpha. Okay? So, it is possible to reduce equation 6.2.7 to a simpler form. If point P coincides with the mass center G for the body. Now, if this is the case, then since nasa center siya, magiging zero yung x bar and y bar natin. Kung ang point natin is nasa mismong yung ano natin, yung center of mass natin is nasa mismo sa point P. Sabi dito, yan. It is possible to reduce this equation 6.2.7 to a simpler form if point P coincides with the mass center of G. So, kung yung point P daw is nasa ano na siya, G. So, wala nang mga distances. No? So, yung x bar and y bar natin will be 0. Therefore, magiging 0 yung first and second term natin. So, that will be equal to here. Now, the sum of the moment at point P, if your point P is nag-coincide sa G, will be equal to I sub G times the angular acceleration. Okay? So, from this one, the rotational equation of motion above states that the sum of the moments of all the external forces about the body's mass center G is equal to the product of the moment of inertia of the body about an axis passing through G, I sub G, and the body's angular acceleration. So, kumbaga, class, take note that this is only applicable when your point P is nag-coincide sa point G. Kung hindi, you will locate the na y bar and x bar, then multiply those each on the mass, and then multiply the acceleration of each component sa x and y, then you can have your sum of the moments. Now, if the case is nasa center, oh no, no, the point P coincide to the mass of the center, a center of mass rather, will be this only. So, simpler na siya. So, again, yung sum of the moments of all the external forces about the body's mass center of G is equal to the product of the mass of the moment of inertia of the body about an axis passing through G or I sub G and the body's angular acceleration. So that's how you compute for the moments, or the sum of the moments of all the external forces about the body's mass center G. So that's how you compute. Okay? So equation 6.2.7 can also be rewritten in terms of x and y components of A sub G and body's moment of inertia. So meron ding another form. So if point G is located at x bar y bar as shown in the figure, then by parallel axis theorem, magiging ano na siya? Eto. So I sub P is equals to I sub G plus M. X sub bar squared plus Y sub bar squared. Kasi nga, yung D squared niya dito, di ba? MD squared to. Di ba? So, ang D squared is also computed by using Pythagorean theorem. That will be X. Ito, di ba? Ito yung D niya. The distance, or the radial distance of the point away from the center of mass. So, to compute for the D, then you can use Pythagorean theorem, which is x bar squared, then plus y bar squared. So, that's how you solve for the D squared. So, magiging I sub P, or the moment of inertia at point P, kung located siya away from G at the location of x bar y bar, then you will use this formula. Okay? Substitute the equation 6.2.9 to the equation 6.2.7, then rearrange the common terms. So from this one, since we already know how to solve for each terms na dito, then we can rewrite that into this one. So I sub p pala, in terms of y bar and x bar, substitute mo yung, di ba, nasolve na natin yung I sub p. Then this is away from x bar and y bar, a coordinate or the distance from the centers, mass, center of mass or mass of the center G, no? So that will be negative y bar m times a sub b sub x plus y bar m times a sub b sub y plus I sub g plus mass times x bar squared plus y bar squared times angular acceleration. Then, simplify lang natin. Then, dito lang yung distribute yung angular acceleration for each terms. After that one, yan, distribute each, and distribute a angular acceleration and the mass each term sa x bar squared plus y bar squared. Then, yan, i-rewrite lang natin. Then we have your negative y bar m times a sub b sub x plus a y squared a y bar squared m plus x bar m times a sub b sub y plus a sub bar x bar squared m plus a sub g angular acceleration. So combine like terms na lang, so that will be negative y bar m, that will be negative a sub b sub x plus y bar a. So that will be ito yung kumbaga simpler form or the um, factor natin. So x sub m, sige, factor dito sa dalawang terms. So that will be x bar m times a sub b sub y plus x bar times the angular acceleration plus I sub g times the angular acceleration. So this is the new new equation if your point P is kind of away from the body center of mass, no, at a specific distance, which is your x bar and y bar. So this is how to compute your moments of moments external, some of all the moments at point P, no, away from the centers of mass G. Okay, so this will be your formula. Okay, so from the kinetic diagram shown in the figure, A sub P can be expressed in terms of A sub G. So A sub G is equals to A sub P plus the tangential, yeah, so tangential component and the normal component. We can express that one. Now express in terms of x and y components. So that will be A sub G sub x sub I, a sub g sub xi plus a sub g sub yj is equals to a sub b sub xi plus a sub b sub yj plus a sub no ak no alpha k times x bar I plus y bar j minus omega squared times x bar I plus y bar j. So carrying out the cross product and equating the respective I and j components yields to two scalar equations. So for the component of at x, so a sub g sub x, no, equal lang siya for a sub p sub x minus y bar times the angular acceleration minus x bar times the angular velocity. So this is how you compute the acceleration at g sa x component. Okay? So for the y component naman is a sub p, the acceleration at point P. Okay? So that will be plus x bar in the angular acceleration minus y bar times the angular velocity squared. So ito yung pag-compute ng a sub g and a sub y nyo enter at x and y component. Okay? So rearrange the equation 6.2.11 and 6.2.12. and substitute it to equation 6.2.10, no? So for equation 6.2.11, so that will be equal to negative a sub p sub x plus y bar times angular acceleration is equals to negative a sub g sub x minus x bar angular velocity squared. So, kumbaga, nire-arrange lang in terms of acceleration and um, its components, no? So, for equation 6.2.12 naman, rearrange lang natin from this one to this one. So, that will be a sub p sub y plus x bar times alpha is equals to a sub g sub x plus y bar times omega squared. Okay? Thus, from this one, since we already have the value for each um, acceleration at component of x and y at point P, so therefore, the summation of all the moments at point P is equals to negative y bar m times a sub g s sub x. Since we already know how to solve this one, plus x bar m times a sub g, since um, times a sub g sub y plus I sub g alpha. Kumbaga, the whole a sub p sub y plus x bar times alpha is equals to a sub g na lang. Okay? So medyo simpler form na siya. Since we already uh, determined what are the values of each terms dali. Okay? As you can see, ang mga left side is equal lang dito sa right side to substitute for our main equation dito sa 6.2.10, which is this one, diba? As you can see here, yung negative a sub p sub x plus y sub a, y bar times alpha is equals only to a sub g sub x, diba? So medyo simpler lang siya. So this will be your result after we determine what are the values of our negative a sub p sub x plus y bar times alpha and a sub p sub y plus x bar alpha. So we just substitute the simpler value, no? And this is a final result. So the equation above indicates that when moments of external forces shown in the figure above, ito, FBD, are summed about point P, they are equivalent to the sum of the kinetic moments of the components of m times a sub g about P plus the kinetic moment of the I sub g times the angular accelerations shown in the figure below. So, ito yung, ang equation na to, nag-indicates lang ng mga, when the moments of external forces shown in the figure above, ito, ang mga moment natin dito, is being summed up, or, yeah, being summed up about point P, they are equivalent. Kumbaga, ito equation na ito nagpapatunay na ito yung mukha ng kinetic diagram from this free body diagram. No? So, that will be the sum of the kinetic moments of the components of ma sub g about p plus the kinetic moment of I sub g a. Yan. So, this is the first kinetic moments. Ito, dalawa. And the kinetic moment of I sub g sub a. Yan. So, yung negative y bar m, ito yon, y bar, ito. And then, positive x bar m, ito yon, plus I sub g a. So, ito yung moment of inertia mo. Or the moment na pa counterclockwise. As you can see here. So, Negative yung Y bar natin kasi nga naka-counter siya sa counterclockwise natin, which is pa-clockwise siya. 'Di ba? As you can see here, ito yung ano niya. So medyo nag-oppose siya sa ano natin, sa positive manner ng moment natin, which is counterclockwise. So negative siya plus yung X is positive kasi nga along concurrent sa positive sense ng moment natin. So, yeah, for to sum up all of this one is this is your formula and solving the moment or external moment of all sum of all the moments acting on our body in terms of the position of our center bodies of center of mass. Now, to solve for that is negative y bar m times a sub g sub x plus x bar m times a sub g sub y plus I sub g times the angular acceleration. Now, a sub g again has a value, or how to compute this one is negative a sub p. You have to get the acceleration, and we also prove that the a sub p sub x plus y bar sub a is equals to a sub g lang. So kung meron ka ng acceleration at point g, then you can use that already to solve directly for the moments at the body. Okay? So much for that. So in other words, when the kinetic moments, no, ito yung kumbaga yung mukha niya, at the kinetic moments or the summation of the kinetic moments are computed, the vectors m times a sub g sub x and a sub g sub y are treated as sliding vector. That is, they can act at any point along their line of action. So kumbaga, um, kung makocompute mo na yung kinetic moments, no? So the vectors, ito yung mga vectors mo, m sub g, m times a sub g sub y, and a sub m times a sub g sub y, they can act at any point along their line of action. So meron kasi silang own na line of action kasi nga mga components to eh. Components ng whole ano mo, force at the center of mass. Okay? So if you can, if already solve for the kinetic moments, then you can solve for the sliding vectors ng ano mo, forces na nag-act sa center ng ating body. Okay? So I sub g times angular acceleration can also be treated as a free vector and can therefore act at any point. So you can write equation 6.2.13 in a more general form, that is the summation of all the moments at point P is equals to the summation of all the kinetic moments at point P as well. So if you can, so again sa kinetic moments, then you can also solve for the moments at point P. Okay? To summarize the analysis, three independent scalar equations can be written to describe the general plane motion of a symmetrical rigid body, which are, first is this one. So all forces along x, summation of all the forces along x is equals to mass times the acceleration at point g at x component along x-axis. So summation of all the forces along y-axis is equals to mass times the acceleration of the centers of mass along y-axis. And then the moment, the summation of all the moments at the centers of mass is equals to I sub g times angular acceleration. So this is your, or eto lang is equals to the kinetic moments, then this is your final independent scalar equations when involving general plane motion of symmetrical rigid bodies. So these are your dependent scalar equations na gagamitin mo when you are dealing with general plane motion of symmetrical rigid body. Okay. So it is important to always draw a free body diagram when applying the equations of motion above in order to account for the terms involved, summation of all forces along x, summation along forces along y, summation of the moments along g or at point g, and summation of all moments at point p. So napaka-importante talaga ng free body diagram so that you can visualize and yeah, di na kayo mag-confuse kung ano ba yung mga equations na kailangan mo i-apply to solve for your unknowns. Okay? So, kinetic diagrams is also necessary to show the terms. Yan. Kailangan natin ng kinetic diagram as well to see the forces na nag-a-act dito also. And saan yung direction ng moment mo when your body is at motion. So, you can see the kinetic diagram. Meron siyang moment, meron siyang forces which is mass times a sub g sub y. Also with here, the moment, to compute for the moment is I sub g times angular acceleration. Then, yeah, that's how you compute for your kinetic diagram. Or that's how you draw the kinetic diagram. Okay? Next, sa part 3 naman. So, let's apply those derived equation when your body is in translation. Again, to recall your translation, it composes of the two kinds of motion, your rectilinear and curvilinear motion. So, just go back to what we have learned kanina and the previous lessons natin. Okay, so it says here that when a rigid body shown in the figure undergoes a translation, all the particles of the body have the same acceleration. Take note ha, on translation, if we say translation, all of the particles of the body must have the same acceleration. Okay? Furthermore, angular acceleration is equal to zero. In its case, the rotational equation of motion applied at point G reduces to a simplified form, which now becomes L summation of moment at point G is equals to I sub G sub A will be now equal to zero, since your angular acceleration equals to zero, then zero na rin yung um, all moments along G. Okay? So you can simplify it to uh, yeah, ma-reduce mo to a simplified form yung formula natin kanina na nasolve. Okay? So when a body is subjected to rectilinear translation, all the particles of the body slab travel along a spiral straight line paths. We already know that one. Now, the free body diagram, kinetic diagram, and kinetic diagram are shown in the figure. So if this is your rectilinear translation, so ito yung kinetic diagram mo. So, line of action niya, dan din yung motion of the body. Okay? Next is the since I sub g times angular acceleration is equal to 0, then only m sub a sub g is shown on the kinetic diagram. Since already 0 na to, hindi mo na kailangan ilagay yung moment niya. Kasi nga, 0 yung acceleration mo. So that's the equation of the motion which apply in this case becomes dyan and dito. Okay? So, kumbaga, ito nang yung mga sa pinakabahaba natin na pag-derive, which, di ba, kung sa napaka ang dami nating dinerive ng mga equations, and we just lead to our rectilinear translation kasi mostly of the problem in the real life situation is mostly rectilinear talaga. When we say, let's say, when you're riding a boat, no, rectilinear, when you're putting a car on a straight line path, on a rocket, mga straight line path, then simply you can have your all force along x is equals to mass times acceleration of g type x component, also with a y component, total nun yun, and then in moment mo lang as zero kasi nga you have no angular acceleration coming from your rectilinear translation. So this is your, kumbaga, to summarize it up, when you're involving with rectilinear translation, these are your cases na dapat mong i-account. Okay? Take note for this one. Now, it is also possible to sum moments about the other points on or off the body, in which case, the moment of m times a sub g must be considered. Okay? For instance, if a point P here, shown in the figure, is chosen, which lies at a perpendicular distance D from the line of action, no, of m times a sub g at the moment will be this one. Okay? So, kinetic diagram na naman, kinetic moments na naman siya. So, all forces, all moments at point A is equals to the summation of all the kinetic moments at point A as well. Okay? So, therefore, that will be equal to the force times the D. So, moment mo lang siya. So, force, so M times A sub G times D. So, this is actually the radial distance or the perpendicular distance away from the line of action to your point A, yung D mo. Okay? Actually, M times A sub G is force, right? Times the moment arm or the perpendicular distance. So, that will be your moment. Okay? Kumbaga, moment lang siya actually, which is, yeah. So, that will be your and summation of all the moments at point A is equals to the mass times the acceleration at point G times the perpendicular distance from the line of action to your point A. Okay? Take note of this one. Therefore, the equation above states that the sum of moments of the external forces and couple moments about A, no, and the summation of all forces, summation of all the moments of point A, free body diagram equals the moment of, yan. So, baga, define lang dito each figure. So that will be equal the moment of the M times A sub G about A, which is the summation of all the kinetic moments at point P. Okay? So this is your kinetic diagram. Okay? So next is the curvilinear translation. So ano yung mangyayari sa curvilinear translation? So when a rigid body is subjected to a curvilinear translation, all the particles of the body have the same accelerations as they travel along curved paths. Again, same acceleration as they travel the curved path. So, ito yung mga curvilinear translation mo. Then, there, your, mag-exist na dito yung components mo. Yung normal component and tangential component. So, ano na mangyayari? So, the three scalar equations of motion are this one. Don't forget again for the translation. So, ang mangyayari dito, this at hindi na siya x and y since meron siyang dalawang axis or components which is your normal and tangential. Now, for your normal, all forces along the normal axis must be equal to the mass times the acceleration sub g, and this acceleration must be at the normal component. And then, same as well sa ano mo, tangential component, there will be all forces along the tangential component or the tangential axis is equals to the mass times a sub g times the tangential axis. So, will be also equal to moments of all moments along point G is equals to 0 as well. Consider an arbitrary point B shown in the figure. And dito point B. If the moments are summed in this point, it is necessary to consider the moments. So that will be summation of all the kinetic moments at point B of the two components, m times a sub g sub n and m times a sub g sub t. Now, the two components are this one. Ito yung first and second component. So, account mo lang talaga if you're going to sum all of the moments in this point sa B. So, meron kang distance na radial distance for your MA sub T. No. Yeah. Kasi nga, sum of all na moment. So, dapat meron kang moment R. And then your force will be this AM times A sub G sub T. Now, for your A sub T, your radial distance or your moment arm from point B will be your H. And then for your A sub N, your mass times A sub G sub M, N, rather, will be your moment arm from point B will be E, rather, will be E. Okay? So, look at this figure. So, mangyayari na, no? As shown in the kinetic diagram, H and E represents the perpendicular distances or moment arms from B to the lines of action of the components. So, meron kang dalawang line of action. So, the tangential action, no, tangential line of action and the normal lines of action. Okay? So, kung meron kang dalawa, then you also have two moment arms. Okay? So, ano na mangyayari dito? So, thus the required moment of equation becomes this one. So, summation of all the moments at point B will be equal to the summation of all the kinetic moments at point B as well. So, ano ba tong summation of all kinetic moments? So, summation of moments at point B will be equal now to the radial distance of the tangential component will be your E times M times A sub G sub T minus, bakit minus? Kasi nga yung positive rotational sense natin dito is per counterclockwise. And then your your tangential will be clockwise as you can see here. Di ba? Bali opposing siya sa counterclockwise natin. No. That will be along or concurrent sa distance natin. So, ano siya. Kumbaga, yung from, di ba, ito yung point of moment natin. So, yung tangential, which is the line of action is pagano'n. So, we can say na move siya pa counterclockwise as well. Right? Now, for your, ano naman, for your normal will be moving against, which is clockwise. Now, to simplify those analysis, so that will be equal to the summation of all moments at point B will be equal to the E. That will be the radial distance of the tangential component of your M times A sub G minus, since minus siya kasi ka opposing, that will be clockwise, the radial distance away from point B to the normal component, that will be mass times acceleration at the normal axis. So this is your new equation, moment equation. Okay? So what will happen now? So that's how you kumbaga mag-a-analyze ka kung ano ba yung moment of yung mag-summation ka ng moment at point B, di ba? So there are two components, and unlike sa linear translation, there is only one line of actions, and now if there's only one, then you can directly equate your summation of all the moment along B as the distance of the line of action, which is the rectilinear, as we recall kanina. Recall lang natin. Ayan. So rectilinear translation, isa lang talaga. So, the mass times A sub G times D. Kasi nga, isa lang yung line of action niya, which is away from point B, away from point A sa line of action, that will be D lang, di ba? So, isa lang. Unlike sa curvilinear, since meron dalawang component, yung acceleration natin, so therefore, meron ding dalawang forces na magka-create doon within at point B, no? So, meron kang dalawang component. So, therefore, you have to account the distance, the radial distance of the tangential component and the radial distance of the, let's not say radial distance, moment arm. No, instead, moment arm, you will determine the moment arm of each component of your acceleration. Okay? So, that's how your curvilinear works in translation sa equation of moment equation. No. Okay, moment of equation. Kasi nga meron tayong tatlong kino-consider na scalar equation of motion, di ba? May no? Meron tayong f of n, meron tayong f of t and m sub g, which is not 0, which is equals to this one. Ito. Okay. So, procedural analysis. So, paano ba i-analyze yung problem when it involves the equation of motion in translation, yung movement ng body natin. So, paano ba? First is you have to identify the given and announce the problem, of course. So, dapat natin ma-identify muna yung mga given so that we can distinguish kung ano ba yung kailangan sa problem. Okay? Next, establish the x and y or n, t, inertial coordinate systems. So, kailangan natin na mag-create ng coordinate system sa inertial natin. Either at point P. So, ano yun, kumbaga, at point P. Ito, kunwari, Ito yung example na ano natin. So for curvilinear translation, if curvilinear yung na-experience ng body mo, then you can create an inertial uh, axis, or yeah, that's what you call inertial coordinate system rather. Okay, next is draw the free body diagram in order to account for all the external forces and couple moments that act on the body. Okay, napaka-importante ng free body diagram, class, so that you can, yeah, visualize the external forces, ano mangyayari, saan yung line of action niya, saan yung kumbaga moment mo. After you draw that free body diagram, then you can analyze, dito pa din mo move, so I can assume na pa-counterclockwise yung moment ko, and asan yung positive axis na kailangan ko, and then you can account all the forces and moments na nag-act sa body mo. Okay? Next is to establish the direction and sense of the acceleration of the body's center. Body's mass center. Okay? Establish the direction sense. The directions and sense ng ano natin, kung asan yung positive, asan yung negative, asan yung para right ko siya, para left, para down and up, and you can, bahala kayo kung asan yung gusto nyong sense na ano. Basta meron kang reference na sa solution mo. Para maintindihan natin kung, kaya pa nag-negative siya dito kasi ito yung inassume na sense of direction ng ano niya, movement or the motion of the body. Okay? So if the rotational equation of motion, no, summation of all the moments at point P is equals to the summation of all the kinetic moment at point P is to be used. And the solution, draw the kinetic diagram because it graphically accounts for the components of m sub m times a sub g sub x, m times a sub g sub y, or m times a sub g sub n, or m times a sub g sub t. And it's very helpful for visualizing the terms needed in the moment sum. So again, if the rotational equation of motion is involved, no, or kailangan mong gamitin, then you can draw the kinetic diagram para ma ma-visualize mo, or ma-assess mo graphically, no, yung mga moments or mga components na nandyan sa ano mo. Kunwari, kung sa translation, kailangan mong i-account kung asan yung component ng y-axis, and then component ng x-axis, and then component ng y-axis. Kung Orwellian translation naman, then you can account the normal axis and then tangential axis ng accelerations mo. Okay? Next, after you establish the kinetic diagram, apply the three equations of motion in accordance with the established sign convention. Again, magagamit talaga yung tatlong scalar equation mo, yung summation of all forces along x, summation of all forces along y, and then all moments, summation of all the moments along at point something. Okay? Point A, point B, whatever. Okay? So, and then establish sign convention as well sa galing sa free body diagram mo or sa kinetic diagram mo. Okay? Next, for the rectilinear translation, this will be your scalar um, equations of motions. Okay? Zero, yung m sub g. For curvilinear naman, zero po din dito. Then you can have up your m sub g, that will be summation of all forces along normal axis. Ito yon, na summation of all forces along tangential axis, and then summation of all the moments at point G. So to simplify the analysis, so equations of motion and other formula. So to simplify the analysis, the moment equation of summation of all the moments along G is equals to 0 can be replaced by the more general equation by this one. Okay? Where P is usually located at the intersection of the lines of action as many unknown forces as possible. Okay? So, para ma-simplify mo yung moment equation na ito, then you can replace that by the general equation na ito. Okay? So, all forces, all summation of all the moments at point P, kung point P yung gamit mo, then you can have your, ano lang to, di ba? Moments, no? Ano yung mga moment na nasa body mo, then i-equate mo lang sa M yung mass times acceleration,
Kung curvilinear ka, meron kang normal and tangential. Kung rectilinear naman, meron kang x and y. Then, no, isa lang pala. Yung, isa lang kasi yung line of action ng rectilinear mo. So, you can just say mass times a sub g times d. Okay? Meron kang radial, no. Moment arm talaga when we say the kinetic here sa kinetic moment. Okay? Meron kang moment arm dito. Okay? Again, for rectilinear, meron lang isa lang na sa naman, curvilinear dalawa. Okay? Take note of that. So if the body is in contact with the rough surface and slight slipping occurs, use the friction equation. Ito. Friction force is equals to mu sub k, or the kinetic coefficient friction times the normal force. No? Then you can solve for a friction force. Again, ang normal force is the opposite lang sa weight mo. So you can solve for your friction force. Then remember that F sub F, or the friction force, always acts on the body so as to oppose the motion of the body relative to the surface it contacts. And we all know that one. Always opposing talaga yung direction ng friction force natin sa motion of the body, no? Or the movement of the body. Let's say for your friction, when for example, your direction of the movement of your body is right, and your friction force must be opposing, so dapat papuntang left. Okay? So a sample of rigid with points considered an external force that acts on a body is shown in the figure. Okay? So meron kang tension, hinihila yung barko mo, as a boat mo, then your boat has a weight, meron kang normal force against your B, point B and point A, and then you have your kinetic diagram since pa tuntang right yung tension force mo, then you can have it here. And then at point B, yung radial or the moment arm at point B, if dito ka magmo-moment, so dapat lagyan mo din ng moment arm. Okay? At point G, since nilocate na rin agad yung center of mass ng object mo, then you can set those boundaries to have your dimension of your moment arm. As shown, weight represents the weight of W represents the weight of the body, T is the tension or the force for pulling the body, and sub B and sub A are the normal forces that acts on a point A and B. Okay, so remember that the friction force always act on the body so as to oppose the motion of the body relative to the surface it contacts. Okay, remember that one? So if the velocity and position of the body is required in the problem, apply the concept of kinematics and kinematic differential equation. Okay? So again, kung kailangan sa problem yung velocity and position of the body, then we can use the kinematics that we have learned previously. So for linear translation with variable acceleration, ganito lang yung gagawin nyo. For that, kung given ng problem is equation instead of a value talaga, so you can use this differential um, equations. Ayan. Ito A sub G D S sub G is equal to B sub G dB sub G. For rectilinear naman with sa acceleration, then you can have this formula na dinerive na natin when your acceleration is constant. Okay? So for curvilinear translation, then you can have your normal components or normal component of the acceleration to be v squared over rho, and then rho is the, again, na masasolve to using differential differential um, kumbaga ito yung radial distance ng object mo to the center of the rotation, 'di ba? Ito yung kumbaga kung kunwari ito yung center ng rotation mo, and then your object is here. Let's say this is your object and it's moving down pa ganon. Then you rotate siya at that sense, so your rho will be this rho, di ba? As we recall for our ano, uh, uh, curvilinear translation, that will be your rho. Okay, this is the distance between the center to the object. Okay, next is the simple lang to, yung acceleration lang talaga niya. Uh, tangent tangent to the movement of the velocity. So, kung meron kang velocity na given, then you can have differentiate that one and then you can have your tangential component. Okay? Same as true with ano, differential acceleration mo. Okay? So, let's have an example. I-apply natin yung mga learn natin, yung mga equations of motion, yung tatlo, yung force along x, forces along, summation of all forces along x, summation of all forces along y, and then summation of all the moments at point P or point G or whatever. So the example states that the car shown in the figure 1 has, or the figure below, has a mass of 2 megagrams and a center of mass at G, and nice kasi meron siyang center of mass kasi most of the problem are not really given na yung G. We have to solve that one. And every shape every shape has its own formula to solve for that center of mass. But anyways, for this problem, determine the acceleration of if the rear driving wheels are always slipping, slip, slipping, whereas the front wheels are free to rotate. Neglect the mass of the wheels and the coefficient of kinetic friction between the wheels and the road is 0.25. Okay, let's solve that one. So given is the car, the distance of the body's center of mass is 1.25 away from the wheel A and 0.75 away from point wheel B. And then the height or the distance, vertical distance from the surface or the road to the center of mass is zero point 0.3 meters. And then the mass of the car is 2 megagrams or 2,000 kilograms. And then the coefficient of friction is 0.25. And then our required for the problem is acceleration of the car, A sub G. Okay. So solution. There are two ways to solve for this problem. The using the FBD only, and then using the FBD and kinetic diagram. So let's first solve it using FBD only. So first thing to do is, since we already distinguish or determine the given and the required of the problem, and then also analyze the problem, where are the values that are given. Next is to draw the free body diagram of the problem to show the force that acts on the car, which is our body diagram is here. Okay, so we have four forces acting on the car. We have the normal force at A, normal force at B, friction force at point B, kasi nga ito lang yung nag-slip. Ito is free to rotate lang. And then our weight, no? So let's solve. So as shown in the FBD, there is no frictional forces at A since the front wheels are free to rotate, yes. While the rear wheels has frictional forces since these wheels are always slipping. So thus the frictional force at B is this one. Okay. So F sub B is equals to mu sub K times N sub B. Okay, so that will be equal to 0.25 N sub B. Then, applying the equations of motion, first applying the equation of motion is all forces along x will be equal to the mass times acceleration along x. Okay, no acceleration on y component since the car moves horizontally. That's way too obvious. But, ninote lang para medyo, meron tayong point then solving this problem. Okay. So, forces along x, since ang nag-act lang na forces along x is the friction force, as you can see at the free body diagram, then, our positive sense pala is from the left. So, positive yung friction force, which is equals to the mass of the car times the acceleration a sub g, which is unknown. Ito yung kumbaga ano natin, isolve natin. Ito yung required ng problem. So 2 milligrams, it's already been um, converted kanina sa given natin. But to show the solution on how. So this is 2 megagrams times 1000 kilograms over 1 megagrams. So that will be 0.25 n sub b is equals to 2000 a sub g. So therefore, a sub g, to solve for the a sub g, we need to find the value of n sub b, or the normal force at point B. Okay, so that will be 0.25 n sub b over 2000. Okay, that will be our equation 1, since we need 3 equations, I guess, to solve for these two unknowns. Our two unknowns here is the acceleration and the normal force at point B. So next equation of motion is along forces, no, all summation of all forces along y-axis. So that will be equal to mass times a sub g and y. Again, no acceleration on y component, therefore this will be equal to 0. Okay? So ang mga forces na nag-act on the vertical component for our FBD is yung positive sense na agad natin is pa-upward. Okay? So, N sub A, that will be positive. N sub B, that will be positive also. Our negative here is only the weight. Okay? So, that will be negative W is equals to mass times 0. So, again, walang acceleration since our car moves only horizontally. Okay. So, substituting the value of the weight, so that will be 2000 kilograms times 9.81 meters per second squared. So that will be N sub B is equals to 19,620 minus N sub A. This is how you solve for our N sub B. Now, the problem is we don't have the value for N sub A. So how to compute that one? Kasi nga, after we solve for the N sub A, we can solve for N sub B. And therefore, we can solve for the friction force or the acceleration of our car. Kasi nga, ang acceleration ng car natin is 0.25 n sub b over 2000. So, we need n sub b. And then, we also we realize that to solve for our n sub b, we need the value of n sub a. But, take note that we also have one equations of motion, and that is summation of all the moments. So, this is the third equation of motion. Diba? As you can recall kanina, third na to. So therefore, all moments at point G, so yung point of moment natin is at point G. Therefore, at A naman, we assume that the counterclockwise sense is the positive sense. Therefore, for n sub A, that will be negative kasi nga papuntang clockwise siya, no? For n sub A. Now, that will be negative n sub A times the distance or the moment arm of the point A from point G, that will be 1.25. Okay? Always perpendicular, class, ha? If your um if your force is acting vertically, dapat ang imong moment arm or dapat yung moment arm mo is horizontally. So that will be 1.25. Okay? So at sub B naman, that will be the moment arm is 0.75 and it is in positive sense kasi nga pa counterclockwise din siya. We need to have our positive at our end sub B to be positive kasi nga para hindi na natin kailangan i-convert i i-convert pa to into positive sense if negative yung ano natin. So we need to assume just to be safe, no? Or just to be easy analyzation. So we assume that our trick lang kumbaga or tips lang. So we need to have the positive and sub B. So we assume na direction ng moment natin will be in the direction for sa as well as N sub B. Okay? So N sub B again, the moment arm is 0.75. Next is the friction force. Take note, hindi dapat, since it is moving horizontally, dapat yung moment arm mo is vertically. Okay? Always perpendicular. And it's acting opposite to our positive sense na counterclockwise. It is moving no, clockwise. Okay, so that will be negative. So f sub f times 0.3 meters. And for the weight, wala siyang moment arms, so therefore 0, so hindi siya counted. Okay? So this is your moment equation, or the third equation of motion. So that will be negative n sub a times 1.25 plus n sub b 0.75 meters minus f sub b times 0.3 meters is equals to 0. So simplify lang natin. So that will be n sub a pala is equals to 0.54 n sub b. Okay? Therefore, our n sub to solve for our equation 2, we have to substitute the value of our equation 3 sa equation 2. Then, ayan, substitute equation 3 to 2 or vice versa, same result lang pa rin. So, n sub b, this is the first or the second equation. And then, substitute natin yung value ng n sub a natin, and then we did determine the value of n sub a in terms of n sub b. So that will be n sub b is equals to 19,620 minus 0.54. Then transpose mo dito sa right. No, sa left. I know. That will be 1 plus 1, 0.154. N sub b is equals to 19,620. So n sub b pala is 12,740.26 Newton. Then after we solve for our normal force at point B, then we can solve for our acceleration. Therefore, for our acceleration, that will be 0.25 n sub b over 2,000. 0.25 times the value of our n sub b, that will be 12,740.26 over 2,000. So therefore, our acceleration for this problem is 1.59 meters per second squared. So that's how you solve for the acceleration of the car using the motion, or the three equation of motion, and the kinetics, the planar kinetics of rigid body, forces, acceleration, mass, moment of inertia. Okay? So this is how you solve for your acceleration involving with different uh, and using your moment dito from center of mass. Then we also relate bakit ganyan yung center mass niya given siya. Then we have to compute for our acceleration here using this given. Okay, so that's how you solve for your acceleration using equations of motion. Again, to summarize it up, first you have to draw the free body diagram. Next is to 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 distinguish the forces acting on our body, which is given na sa FBD natin. And then use apply the equations of motion that we have learned, which is this one, first equation, second equation is this one, and the third equation of motion is the moment. Okay? So after you already determine those unknowns, then solve for the required of the problem, then you can have your final answer. Okay? So, next is your solution using the kinetic diagram. So, paano ba, saan ba mas madali? But, you just have to, show na paano ba gawin with using kinetic diagram. So, the acceleration of the car can also be solved using moment equation about at point A. Okay. So, FBD and kinetic diagram is necessary to use this method. So, we need a kinetic diagram and FBD, okay? So, since you already have the FBD, then for kinetic diagram is papuntang left siya. Then we have 2,000 A sub G. This is the mass of the mass of the car times the acceleration at point G. Okay? At point G is, that's how, that's is our unknown. Okay? So at point A, we account the point A at the front wheel of the car. And then it is 0.3 meters away from the center, from the body center of mass. Okay? So apply the equation of motion at x component using FBD and moment equation at using FBD in kinetic diagram. Ayan. So, again, same lang pa rin yung sense. We are going to use the equation of motion to solve for the unknowns. Ayan. So, okay. So, we already have our all forces along x. We already know na friction force lang yung nandun. So, to solve for the A sub g, then 0.25 n sub b 2000. Yan. So, this is our equation 1. Okay. Next is the moment. Then, equate natin sa kinetic moment ng ano natin, car. Okay? So, all summation of all moments at point A. Ayan. So, n sub b. So, n sub b is 1.25, no? Away from point A. Take note, away from point A. So, that would be 1.25 plus 0.75. That's the distance away from point A, yung n sub b natin. Minus weight. Weight is away 1.25 away from the point A, so that will be negative. Again, since the positive sense of the rotation is counterclockwise, and then the weight is clockwise siya, so that will be negative. So is equals to the kinetic moment at of the car. So or at point A, di ba? Kinetic moment at point A, di ba? So that will be 2000 um a sub g times point 0.3. So this is your a sub g, 2000 a sub g, di ba? Dito yung kumbaga kinetic moment formula natin. That will be the mass. That will be mass. This is your mass times a sub g, di ba? A sub g times the moment arm or the distance away from the point of the moment. So, G to A to A tapos G to. Then yung mass mo is 2000 kilogram. Your acceleration is unknown, A sub G, and then the moment arm is 0.3 meters. So, yeah, from this equation, then we can solve uh, another equation. So, yan, 300 a sub g plus 12,262.5. Then, by two unknowns or two equation and two unknowns na pag-solve ng ano natin. So, substitute equation 2 to 1. Then, you can have your a sub g. So, n sub b here is equals to 300 a sub g plus 12,265. You just have to substitute that into equation 1. Then, you can solve for your a sub g directly. So, hindi na kailangan natin mag-account sa second, ano natin, diba? Second equation of motion, yung all forces along y. Since we just use the forces along x, since doon natin makukuha yung acceleration natin, and then after that we solve the kinetic moment using this one, then we directly solve the unknown of the problem, which is the acceleration, which is equals to 1.59 meters per second squared. Okay, so I think that's all. That ends the lesson for today's video. So I hope you did learn something from this one. And then again, to summarize, we did discuss the moment of inertia, the equations of motion, and we also solved for the we also discussed about the what do you call this, equation of motion if your body is in translation. Okay? So, meron din tayong equations of motion when your body is moving in a rotation about a fixed axis, and that will be discussed next video, lecture video. So, again, um, to sum it up, that will be your lesson 6. And thank you for listening, and I hope you did learn something. Thank you, class, and goodbye.